Good, whatever time of day it is you're watching this. Today I'm going to be starting the process of disassembling my electric bike battery. I fell off the bike and part of the pack, it was this top corner there, was the bit that hit the ground, and yeah, so that shorted out 3 of the cells and melted some of my little bus wires. But basically it's made out of, these are the actual packs, these long thin, this whole segment here was the original pack size, and these were harvested out of robotic lawnmower batteries. And so what we're going to do is we're going to basically get rid of all this plastic and all the original spot welds and everything, get them all taken off, and we've got some new holders for all the cells to go in, and we've got a new spot welder to try out. So we're going to reassemble this pack. We've got a couple of cells to replace 3 or 4 damaged ones, but first we're going to strip all this down. At the moment I've got the 3D printer printing out some cell spacers, but after looking at it, for the sake of doing these packs, I mean they're £6 for 100 end cap pieces, so I'm not actually going to use the 3D printed ones. So these are the packs were originally. You had 9 cells all together, all teed up, and that would be one battery pack for whatever brand of robotic lawnmower it was. Obviously I needed a 14 cell pack, so I had to add an extra that many, 1, 2, 3, 4, 5 onto the end. So they were basically joined on like that, and that was one row of the pack, and then stacked up. I think it was, might have been 10 cells high by 14 wide, 140 cells, something like that. So I'm now going to strip all this, the old outer casing off. You can see all the little copper bus wires I had going across. But yeah, I've got to get all that off, and hopefully make a battery pack that's a little bit more durable. We're using a BMS. What was it? This one, a Dali one, 14 cell 48 volt BMS. So that's that. And obviously here's the balance wires which were cut off. They all need to obviously go back on at some point. Now, yeah, we've got to strip it all down. Right, so it's now quite a bit later in the day, and I've finished moving all the 18650s from their casing. When I say it's later in the day, it's dark now. So it's taken a while. There's plenty of these things to go about. Yeah, that's took me quite a few hours to do, to get all these batteries out. The next problem I face with these batteries is obviously they've all got the old like little bits left over from the spot welding. How that's going to affect my ability to spot weld new tabs onto them, I don't know, but that's basically it for today. That's all I'm going to do. These are only Samsung INR 15Qs. They're 1500 milliampere each. I mean, they're not the biggest, best cells you can get nowadays, but I got them cheap, so, and they're all good. They're all good. Every single one is good cells. Right, we're now on the table. This lovely space with lots of junk in the way. Don't want to push it all off the table. Now Thursday, beer in hand, there you go, and lots of parts have arrived. So in these lovely bags, we've got some of these things. These are basically, they are 18650 holders, which are modular, so you can put them together like so, getting the right way out, and they all slot together very nicely, and we can build our grid of battery like so, something like that. So yeah, let's zoom down on these a bit so you get a better idea. They're modular, so I'll move that out of the way. We've got these, they have 2 sides, and this is the top side. So they've got 2, they're like jigsaw pieces. So if we notice, these ones have got the spiky bits out both sides. Get them both the same way, then we can take them and slot them together slot them together like that, and then you can add them onto the top of other stuff like that. Ow, that's a piece of metal in my finger, but we can add them on. These ones have to go on the top. I have no idea how they fit together. Yeah, they go on the top like that. So something like that. There you go. Modulating 650 holder. You get your 18 650s and plonk them in. And do the same on the top side. And yeah, then you can build up your battery pack. Good, eh? But wait, there's more. So we put all that stuff out of the way. I have one of these. That. This is a spot welding pen with springy terminals. They have a small amount of spring to them. Relatively heavy weight. Big old connector thingamabobs. Looking quite good. Heavy. But wait, there's still more. We have a battery holder for 18 650s to, if you're going to be doing smaller packs, you could put them positive negative, lay the terminal strip across and then black them away. But obviously there's something missing here. So in the box got some connectors, a few of them knocking about, you see what I mean? We got some 0.8 by 0.2 mil, what do you call it, nickel, pure nickel strip, apparently pure nickel. Find out later, might as well chuck it in some salt water overnight, see if a piece of it starts rusting. Woohoo! I have another bag of plastic thingamabobs. We got ourselves a foot switch. That's a bit late on that. And what else we got? Got loads of bits, more steel, some fuses and bits, spoke tightening, got some handlebars, another handlebar, got some inner tube, got some inner tubes. Yeah, it's not really what we're looking for, is it? We're after the main event, so if we put this stuff back in the box, because we don't want that, we don't need to tighten our spokes right now, and we don't need any of this steel or any of the included fuses. What we're waiting for is the Sunkko. Here she is, the 737G spot. Oh, sorry. Steady, you alright? Yeah. 737G Sunkko intelligent precision pulse welding machine. I've already had this running and tried it because it had problems. Believe it or not. How does this work? Oh, so it's quite smart. So when I got this, so when this lovely machine arrived, there were some problems, to say the least. I opened up the box, took it out its packaging, and there was a rattle inside. Not a little rattle, like a big, heavy, chunky metal rattle. And what happened was, if we turn it on its side, you got these 4 screws in the bottom. These 4 screws are very important because they hold the transformer onto its plastic base into the inside of the machine. There was 2 of them left. The other 2 were inside the box just rattling around. So I thought I can't power it up like that, I've got to open it up and have a look. And if you've seen videos taking these apart before, it's pretty self-explanatory. I could open it up, and I might open it up, but you can also watch other videos of people opening these up. Right, so in here we have this lovely machine. This is the transformer. So this is where all the voltage gets, well, there's a 240 volt coil, or a 220 in this case, and it's only the primary windings that are in. The secondary windings are literally this thick copper bus wire you can see here, Yeah, it's relatively thick. It's not like, I don't know, it's a bit, it is what it is. But it should, might do the job. If not, we've got to modify it. But if I look inside, it's one turn. Sorry, 2 turns. It goes in, round the transformer, and round and out, and that's it. So it's taking in the AC voltage. 2 turns. What are we expecting? Like maybe 3 volts coming out of these 2 leads. And these 2 leads are the output leads here, going up to the switch mechanism / welding mechanism. So when I got it, let's have a look. These little screws and nuts here. There we are. Oh, there goes my torch. I forgot that was the only gently bottom one. So these nuts and bolts here, 2 of these had disappeared and were rattling around inside the case. The other 2 were barely holding on for dear life. You can probably see that the actual mounting bracket at this end was a bit bent, because it was only the front 2 that were left hanging on. It is what it is. So I screwed them back in. Same on this side, same thing. Obviously this transformer has the mains voltage winding. I was about to say, maybe it takes a piggyback off the transformer to run the board, but it doesn't. The board actually runs off mains, so the mains goes into the transformer, well sorry, goes into the board, is rectified by the full bridge rectifier, and yeah, the board then uses its voltages as needed. So I didn't think would be the way it did it, but that is. And then the board actually outputs current to run the transformer, so it controls the duty cycle of the transformer. Rightio, so now we're there, we can understand that. We've got a twiddly thingamabob up here. There we are. And all this does is control the amount of pressure required to actuate. Hold on. Over here. God, it's better backdrops you can actually see. But these are the welding probes on this end. And you can hear the click. This just adjusts the amount of force required to meet those limit switches built into here, which actually turn on the welding current for the specified amount of time, and the current amount, which isn't actually a thing, it's more like a PWM. I don't know, I haven't really looked into it that far. Yeah, you can do it that way. Or, now we're going to zoom out. See if I can put the torch back where it is. Yeah, self-mounted torch. So, on the front end here, we've got obviously the probes that you push against, they lift up. And I'll put the probes in, because I was just trying it to make sure it actually works before I bother making a video about it. We've also got the pulse and current, so you can do 1 or 2 pulses. So you put it on and go did-it. We'll probably be able to tell that from how much the lights flicker in this place. And you set the current, which is 1 to 99 something. But if you want to go the other route, you can plug in the foot switch into the welding cow control socket, whatever the hell that means, and then you've got a foot switch, which basically means that's the way we're going to use it, because we're going to, as you might understand, this welding pen, there's nowhere to plug it in. It doesn't plug in here, doesn't work, there's no way to connect it. So something we've got to work out, but maybe rewind the transformer yet to make it more powerful. I don't know, we'll see how we go. But that's it, that's the problems I had when I got it. It wasn't a perfect machine, and this only came from the UK to the UK, so maybe it left the actual seller rattling about, the transformer just banging around inside. So, I don't know, how about we try and do some welding, spot welding. Right, the screws back in, switch her up, and bring over a 16 amp extension lead. Now you may think, what? Why is the bloody in the way? And you might think, why I'm bringing over an extension lead? I'm not plugging this into the ring main in my house, I'm plugging it into the cooker socket. Yeah, oh sorry, yes. Turn it on. I'm plugging it into the cooker socket because this thing's going to draw some power. I mean, it's going up to 16 amps when it's working, and every time I operate it, my lights in here don't flicker. I can make them flicker. Hold on. Right, we've just, oh, my heater's gone off. We're back. Okay, switching the solar off does upset the heating, so I'm going to turn off the light. You're going to watch what this does to the lights in the building. Just give you a better idea. Let's look out the door. I don't know if you'll be able to see it, but it's making the lights in the entire building flicker. Why? Because it draws a lot of current. So now we don't need the torch because we've got this lovely underlighting built into the probes here. Yes. So at the moment it's set on 2 poles and maximum current. I don't know if that's a good idea, but we're going to try it. So I'm going to get some stuff together and we're going to give it a go. The thing I should know about these is you've got to build your rows with your lugs facing that way and that way. You've got to build your entire row first, then put your next row on top. Because the way they work, with these flat feet on the bottom, you can't slot them in either way. They've got to go in sequence, because you can't get to the bottom of these rows because they're capped like that. So you've got to build them rows going up. So you've got these or this row, and then the next row is going to go on, but this row's got to sit on top of it. So there's no adding more rows afterwards. What you got is what you got. So you've got to do it right in the first place. So it's me pushing it all together, probably getting it wrong. God, they're tight, which is a good thing. I suppose being tight and fitting nicely is a good thing, because that's actually quite rigid now. Yeah, it's flexy, but it isn't going to fall apart. And yeah, so you've got to obviously have top and bottom. Well, I've got 140 cells and I've only bought 200 of these plastic things, and I'm not going to be able to finish it, am I? Right, so now we're on the spot welder. I'm going to put my foot pedal where I can't get to it. I'm starting to make a few test attempts at welding some packs, and yeah, I've got the foot pedal connected and I'm finding that it's fine using these probes. I'll put that back there. It can make a weld quite nicely, and I'm trying to weld this piece of nickel strip to a 18650. It welds very well and it's very strong, but for what we're doing, e.g. making a massive great pack like this one, this, would you believe, if I can get off the welder, is only half the pack. I mean, it's got to come out to double the width, and you can buy these spot welding pens, which are all good, and they come with their own wire and the connectors, which are fine, but these don't plug into my spot welder. So I thought I'd try pulling the wire back, the insulation back. There's a bit of insulation there as well. This is just spiral guard, but there's insulation there, and removing the bolts off the front of the Sunkko here and clamping them there and there, both terminals to both of them, and you suddenly find that there's no transmission, there's no power. It basically doesn't spot weld. It's mainly down to the gauge of the wire isn't thick enough to support the amount of current we're asking from it, I should say. If we unwrap this, see, it's fairly thick copper wire. I mean, it'd probably work on a different system, but on this machine it's not good enough. The only option we have at the moment is to use the front probes for welding. Because I've got the foot pedal in, they're not set to automatic now. As you see, when we welded that, it worked fine. And we'll do another one just to show again. It's annoying because it's bright. So when we work off the side, There we are, so you can get an idea of what's going on. I find with the foot pedal's gone, we just press down, we're not pressing down very hard, and tap the foot pedal. You can see a bit of smoke came out. Put another one next to it, there. And yeah, it has really stuck. So things have progressed quite a bit. This obviously wasn't going to do the welding job that I needed it to. I quite like the control system, so what I've done is I've pulled the transformer out, which is right here. Sorry, it's out of shot. There we go. And I've removed the original transformer winding, which looked like this, right around inside of there. This is some pretty thin wire, and I've replaced it with some, this is in England, so we're on 240 volts, but I'm going to be using 35mm squared wire, which I have stripped the insulating jacket off of. So see, I've stripped this all off, so probably about 2 meters of cable, and this jacket's been stripped off up to that point there, then wrapped it in tape. Don't ask what tape. I'd usually use Kapton, but I don't have any, so it's sellotape. And I'm going to it's not good, don't use sellotape, that's a terrible idea. But I've wrapped it round, made sure it was flat, and managed to pass it through the inside of the transformer twice. And then I'm going to shove some insulators to insulate it from the iron core of the transformer. Then took the end, and it's obviously the original flex and the other flex. As you see, that's quite a, compared to, where is it? Here, the actual diameter of the copper, there's quite a substantial difference. So that, and it allows me to, if I can get some distance from the actual machine, oh, she's fallen over, with my new leads. Not a lot. I don't want to go mega distance, because the more distance you add, the thicker the copper needs to be, and your bottles drop, blah blah blah. Moving the transformer is pretty simple. There's 4 bolts that hold it down, and there are 2 wires that provide power to the transformer. I've cut them. They are soldered onto this circuit board at the back, but if you cut them, and you've got a soldering iron, you'd be able to just leave a bit on there so you know which was red and black. Easy as that. It doesn't matter, it's AC anyway, who cares? You've also got this little temperature probe, which was just like stuff in the front, and all you just kind of just wiggled it and it came out. I didn't have to cut anything or damage it or anything stupid. The next bit is I've also got to get these big new thick wires outside the casing, and you don't believe it, it's almost like Sunkko wanted us to modify it, because if we look inside here in the casing, I turn up, let's move the big hefty battery out of the way, look inside the casing, look, see that? This bit here is a pre-cut out in the casing, where they must have obviously intended it be for the probes or something. But if we look, I can bend that and snap that out. All I need to do is trace around that with a knife, and that piece will bend and snap out, and then I've got a exit hole for my terminal. So I'm just going to trace around it with a knife, and we'll snap it out. Hang on. Yeah, somebody's thinking ahead. Because I've got this nice unshielded cable, I reckon we use a bit of the old yeah, we can use a bit of the old rubber shrink just as a protector of the cable. So if I slide it back on like that, wiggle it, stuff it in there. There we go. We've got made ourselves a kind of cable gland, if I could actually keep it shoved up there far enough without letting it come off. Yeah, what do you reckon? Where do these screws come from? Oh, I know. Yeah, whatever. Not important. Look at that. Look at that, people. nicely protected wires. Yeah, it's not beautiful, is it? But there we are. Two nice big heavy duty cables coming out of the machine now, which I can then attach to some copper rod or bodge attached to these. Maybe we could make some decent spot welds, or blow some holes in lithium batteries. One or the other. Is it going to work? I've got some nickel plate. Don't know. Going to melt a hole in my table. Have I made it worse or better? I don't know. It's welded. I can't tell because I can't find my battery that I was using. Heaviest. Ooh, most annoying spot welder to use in the world. Don't worry about the rust. Ignore that. Push down. 3 presses of the pedal and we got nothing. Good job. Now, is it because I haven't insulated the transformer? Or is it because I'm using these cheap nasty probes which probably aren't very good? I don't know. Trying not to burn the place down. Oh shit. Right, here we go. Let's go on that side. Oh dear, we've got some warmth in there. Oh my god. Can you see it? There we go. Let's get you raw in the picture. That's 100 degrees in there. Have I actually cooked the transformer already? I'm sure that's not my windings. It could be. It isn't looking great, is it? What about the average? Yeah! Maybe my windings aren't so good. The leads were starting to warm up as well. Ignore the tin, which is also because I had my hands on it, but the cables are starting to warm up. And this thing, which is also quite warmish. Yeah. Rightio. Remember what I was saying about the limitations? Let's get off. Yeah, she's pretty hot. Oh dear. I think I need to finish the build first. But yeah, this is what I'm messing with. By the end of the day, this will be dead. I'll have to buy a new one. Right then, so now on the next day. So yesterday I was just messing about with it, making a right mess of this, and not really producing anything useful. So today I decided to disassemble the transformer again, but this time obviously I've got the same 35mm red cable, which we've stripped, giving ourselves a good, I don't know, 400 centimeters, nearly half a meter of cable to use as spot welding outputs. Nice thick cable, and stripped half the insulation off. Well, not half, more than half, because you've got to obviously do two. I'll go into the transformer round and then out, but this time I've decided to better insulate the actual internal windings. And what I found, another idea, obviously you get this hard plastic cardboardy type stuff. I've decided to leave that in but slide it on the outside to protect the wire from the hard steel lamination, so you can see how it's in there and it's protected it. So what I did is I unwound the cable that I put on with the clear tape, and I got the cable and spread it all out. It's several groups, say what would it be, 6 being natural laces, of 1 in the middle and 5 on the out, I don't know, something like that. But I spread them all out so I could lay them flat, and then I taped them loosely while holding the wire flat all the way along. So I've ended up with this nice flat taped on type cable. It's not perfect, but it's allowed me to actually get 2 wraps round the transformer. Well, a wrap in, it goes, sorry, in, around once, down, around again, so technically it's 2 winds of the transformer. And by having these plastic car body inserts in, it also allowed it to go through without being cut on the edges here as it shoves through, and that seems to have worked quite well. It also means now the transformer is insulated. The wiring is no longer in contact with itself, which I can guarantee it was. It also was in contact with the iron core. So we're going to try this today. I still don't have any proper ends. Well, I have somewhere, but I'm going to see if I can find them, to see if we can attach these 2 leads to them and try and actually do some spot welding, and maybe turn the current down on the machine so it actually can be used rather than it always being flat out all the time. So that's where we are at the moment. We've got our transformer and some nice leads coming off, and we're going to go from there. See if we can make this this Sunkko, what is it, a 737G, a bit more of a useful machine. So the other thing I think would be worth looking at is these spring-loaded probes, see what makes them tick. So obviously they got this metal piece on the front, which I've undone the screws, just because I want to know what's inside essentially. What makes these worth £40? So let's move the transformer a bit. So you got like the probes themselves. There are some kind of separatory thing in here. We'll just do it with one piece of steel, some random sticker, and this is the, I see, so it is, the sprung assembly is actually the copper wire directly connected to it, and that's how that works. We can go further and take the actual, so try not to lose the spring. It's not like it can go anywhere, is it? Because it's attached to the piece of wire. Can we get this out of here? I'm sure we can. Get a better look. Surely it's as simple as that. It's just pushed in, isn't it? How do you get it out? Force. That's how everything's done in life. It's probably forced together and it's going to be forced apart. It says, still not been able to go. There she goes. Right, so it's just the copper. Now, relatively nice and heavy. This bit doesn't echo the same. So the copper wire goes in. It's obviously the same way it was done on the transformer end of the actual windings of the transformer, and it is just the copper wire, wrap of copper with the grub screw. It's not a proper like ferrule, it's literally just a wrap of copper they put around it like that. So it's not a proper ferrule or anything, it's just something, it's crap. So anyway, they've done exactly the same thing here. I wonder if I've got a radio, I've found one, Allen driver. I bet it's the same factory. It's got to be the same. Well, I don't know if it's the same factory, I bought it from a different place. No. So this is different again. So they've taken the copper wire, shoved it into, I'm trying to think what this process is called. It's where they heat it and fuse it together. But it's not a copper lump of junk over the end. It's actually, this copper braid has been, I don't know what you'd call it, thermally fused together
with heat. But this, that is just, there is no weight in that. That is made out of the cheapest, nastiest junk they could find. I'm just looking around for maglances at the moment. Copper? Do you reckon that's copper or not? It's, that bit's magnetic, the steel grub screw. I don't know. Trying to scrape a bit of the side off and see. I'll scrape into it a bit. One moment. It ain't copper. So when people have trouble with these things, it's more or less likely due down to the quality of this component, whatever this is made of, because there's no weight. It's a very light material. Doesn't feel like aluminium, but you can. It's quite soft. I mean, scratching into it doesn't take much effort. Biting into it with a pair of these pliers, which most of you will know isn't, I don't think, aluminium. Doesn't take much to make quite a significant gouge in it, whereas if they were copper, it'd be about the same, but it isn't heavy enough. You mark that up against this piece of wire here. Ooh, that's heavy. That feels like it's made of tin, or if I didn't know better, it feels like this bit was made of copper, that little rod in the end, and this bit was made of plastic. That's what it feels like. That's how light. I understand. It gives me a reason to know why these things are total junk then. These are a waste of time. Don't ever bother buying a set of these. The only bit that's good is actually the nice heavy copper wire, but as soon as it gets to the termination point of this, yeah, that's where you lost. That's where it's all going wrong. It's losing all of its power at that point. So when people saying that these things get hot and the springs start to stick on them, it's not surprising really, because this portion of it's going to get so damn hot that it's going to cause, well, that's why the springs stop working in there. It's because this bit's got so hot it's melted everything. Anyway, due to my complete impatience and inability to wait for anything to turn up, I built my spot welding probes using the tips out of the spot welder. We're over here. See what I've done? I've taped them onto the end. Now this machine makes the lights seriously dim. So what we're going to do first, take some of this stuff, put it together, and we're going to use something from here, but it's still on maximum current. Definitely made a connection, and it got that hot, melted into the 3D printed part. Wider. There we go. The lead, nice and good there, and go. Little whiff of smoke. Fire today though, sorry. And we're going to try. I think we're about there with that. We've ripped the nickel sheet in 2 places. But it wouldn't be my channel if we didn't put her at 99%. Don't put your fingers on the back of the circuit. Or 99%, 2 pulses, ready to go. Yeehaw! Let's see what happens. This nickel sheet, and these are cold. Not even. There's no warmth in these wires yet, I can assure you. Which you kind of expect for something like this. Right, 3, 2, 1. Not as much as spark that time, but oh yes! Ooh. That was welded on tight. 2 holes, a good rip, good adhesion. It's running it at like full power is basically the way forward by the look of it. What I do want to find is another one to try. Right, today's another day. As you can see from this, the batch pack is built.
I've got what is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that way, 14 that way. Make it a 1410p. And I've already started. I started doing it and realised, oh yes, I'm supposed to have done a bit of an update on the filming of doing the spot welding on these. I didn't bother cleaning the what's left over on these. I figured if I push hard enough, I can push down and make the strips connect. So if we zoom in and try and get you a bit more centred, I've got these lights, which they're there. Can't do a lot about them. Obviously, this is the modified Sunkko with its extra leads running out the front of it. And all I'm doing is getting my nickel strip, getting it roughly where I want it. Obviously, we've got to about there. And cut it off away from the battery pack because it is a relatively well charged battery. It's pretty much full-ish, about 80% charge. Lay that on there. Then push it back a bit. First one, I still haven't built my new probes, but we're making do with what we've got for now, just to see how we get on. I have actually got the probe rod, but I just haven't made it look nice yet. There. Lead around. One. So I'm doing 2 spots per battery. As you probably see, really, look, that's well connected. Good enough what we're doing. I'm going to come about halfway along, or if I could reach all the way I would, but I'm not going to. Just going to tack it as is for now. Just get the leads around the right way. Not fighting with them too much. Keep it roughly in the centre. There. 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 Ooh. Just go a bit there. So yeah, we're making progress. Just get you a close up on some of these welds that I'm about to do. Let's go for 2 here. Should be able to see them. You see my leads aren't brilliant at the moment, but they are doing the job. It's all they need to do. Can you see? Yeah, you can. Okay. That's where the lead's gone a bit a bit off track. But it's doing the job. As long as it reaches, and the job is done. Okay. There's the whole pack, the whole strip done there. Yeah, the spot welds are relatively good on these. They're not brilliant, but they will certainly do. I mean, they're not falling off anytime soon. So, see, we're still using the machine without the casing on. Couldn't bother to put the casing back on because I'm still messing with it. But no, I've got quite a bit of work ahead of me to do all of this. Probably haven't got enough terminals, well, of the nickel strip because I've only got 5 meters. And I haven't added all this up, but we've got to go across on both sides. Then we've got to do a link there, a link there, a link there, a link there to link the actual strips together to make the pack go from positive to negative, positive, well, yeah, positive, negative, you know, it's got to link up to make the voltage correct. So, the only things I have noticed is this lead's a bit short. I can't really reach across the whole pack. Kind of wish done it slightly different now, but I've actually got more cable. So what I might do is put a connection block in here somewhere in this area and bring the cable a bit further away and I'll show you what I got is, I think it's 2 meters. I got a couple of meters of red 35mm stranded cable. Very nice and flexible wire this is, because you want it to be nice and flexible. It's annealed, so it's nice and flexible, unlike the stranded stuff you get in your fuse box with house wiring. Yeah, it's definitely 2 meters. That's a good long length for this stuff. So I've got enough to play with and make some changes. The other thing I got, stupidly packaged, copper rod. Comes on a piece of cardboard, because I don't know. Oh no, it's actually, sorry, it's taped to a piece of wood. And this was I'm gonna cut this in the middle and then sharpen it to points, but not sharpen. You leave a square flat end on it, so I'll be able to use 2 of these connected to these, something along the lines will be connected to it, and then I've got a couple of probes that I can just do. I don't know, but yeah, that should do the job, shouldn't it? Cut them, push down, clip, because that included silly orange thing. That is never going to handle the amperage. So let's do one more. I'll do this time, in order to stop it moving around so much, try and get the other end spotted in, fused on. I'll go as far as here, that'll do. There we go, that's now connected, so this is just floating on the top, and we go along. Blimmin', this probe's moving further and further up inside the tape. Still makes the house lights flicker every time. It's getting to the point it's getting ridiculous, because this probe's now moving up inside the tape, so I can't actually see it anymore, making it slightly harder to do the job. Only trying this out this evening just to see how well it actually went, and yeah, it works. It's not perfect. I've got a bit more of the probe exposed now. Let's see if we can get an idea of the last couple. This one I've already put 2 tabs on already. Try and do it a bit more of an angle so you can see a bit more what's going on. That's it. Last and most certainly least. There and there. That's it. That's how it's going. And spot all seems to be relatively good. They're holding on quite well. So yeah. Running it on 2 poles, 99% current. So basically maximum power, just because might as well. It's not blowing the holes in the cells, and seems to be sticking quite well. So I would say I try pulling some of it off, but I don't want to ruin it. So that's how we're getting on at the moment. You're out of battery, so that's all for now. We're going to get the better probes and do this properly and maybe extend the wires.